Okay, I hope it's unfrozen. So on the right-hand side, we have the multiplication between x and y. So we need to be very careful here. Why? Because we have to apply product rule. We need to take the derivative with respect to two variables. It's a multiplication of two variables. We take the derivative with respect to x, then we take the derivative with respect to y. But note that we have 6xy. We take the derivative with respect to x and with respect to y. So you have two variables involved here. If you want to take the derivative with respect to x, it means that your y considers as a constant. So the derivative 6xy with respect to x is going to be just 6y. To take the derivative with respect to y, your x is a constant. So it turns out this is just 6 times x. But since we have product, we have to add these two derivatives together. 6y dx plus 6x dy.
Could you also show how you did the left side?
Which one?
The left side of the equal sign, yeah.
So the derivative of x cubed is 3x squared dx plus the derivative of y cubed is 3y squared dy.
Okay.
The derivative of each of these separately, we're not really worried about them because this guy doesn't have any y in it, this guy doesn't have any x in it. So just directly taking the derivative with respect to the given variable. The given variable here is x, taking the derivative with respect to x. The given variable is y, taking the derivative with respect to y. But here you have multiplication on the right-hand side. Well, what's the meaning of that? It means that you have to take the derivative with respect to x first, then take the derivative with respect to y. If you're taking the derivative with respect to x, it means that y is a constant. So this guy is a constant, you copy it down. It acts like 6. It acts like 3, a half, a fourth, anything. So 6y as a constant, you copy it down. The derivative of x is dx. That's it. Taking the derivative with respect to y, it means that your x is a constant. So 6 times x is a constant. You just copy it down here. Taking the derivative with respect to y result in dy. Awesome. So our next step is to have dy over dx isolated on one side. Now isolate dy over dx on one side. How do we do that? Well, first of all, we have a lot of dx, dy here. First, we need to get rid of all of the dx's. Divide by dx, we have 4 fractions, 4 terms. Divide by dx, divide by dx. Okay. You end up with 3x squared plus 3y squared. Dy over dx has another notation, y prime equals to 6y plus 6x y prime. Okay, I have y prime on the left, I have y prime on the right. I have to do the subtraction. Step by step. Minus 6x y prime equals to 6y. Now I have to bring this guy to the other side, so minus 3x. Now we can factor out y prime. You end up with 3y squared minus 6x equals to 6y minus 3x squared. Then divide everything by 3y squared minus 6x to isolate your y prime on one side. 6y minus 3x squared divided by 3y squared minus 6x. This is the derivative of the function. At each point, you get a rate of change. It might be positive, it might be negative, it might be 0, depending on the behavior of the surface or the object in this case. There you go. So sometimes we end up having cases that we